All right, Im2 peeps. Let's do problem number 8 together. Hopefully you're doing well. All right, in problem number 8, we are given the factored form, and we want to turn it into standard form. So it's kind of the opposite of what we did on Tuesday. So to turn factored form into standard form is very simple. All we're going to do is multiply it out. Okay, and what I mean by that is we're going to go x times x. That gives me x2. X times 2, that's positive 2x. And then we're going to go 4 times x, that's positive 4x. And 4 times 2, that's positive 8. Combine like terms here, 2x and 2x, that's going to give me 6x. So x squared plus 6x plus 8. And then we cannot forget that we had a negative 2. So the negative 2 is going to go here, and we're going to multiply that in. So negative 2, and now let's multiply that in. Okay, so negative 2 times x squared, that is negative 2x squared. Negative 2 times 6, that's negative 12x. And then negative 2 times 8, that is negative 16. All right, and now we have our function in standard form. Okay, so just multiplied it out. We're good here. Now to find our x-intercepts, remember x-intercepts, we're going to take our factored form and put each factor equal to 0. So in other words, this f of x here, we're going to turn it into, think of it as y now. Okay, we could replace f of x with y. And all we're going to do is, our goal is to solve for x. So to solve for x, or find your x-intercepts, to do that, we're going to put y equal to 0. So if you look, my y is here. I'm going to replace it with 0. And now we have this equation to solve. So to solve, we're going to take each factor with an x in it and set it equal to 0. So x plus 4, put that equal to 0. X plus 2 equal to 0. So in other words, we're solving by factoring. Okay, so if I solve here, I'm going to subtract 4 from both sides, and x is equal to negative 4. Over here, subtract 2 to both sides, and x is equal to negative 2. Okay, so our x-intercepts, we want to put these. Oh, before we go on, notice I didn't put this equal to 0 because it doesn't have a variable. So this is actually a factor, but doesn't have a variable. So what I want to do is put these in point form. So point form looks like this. Our x value, and then we know our y value is 0 because of what I mentioned over here. Remember, y is always equal to 0 on the x-intercepts. And this guy is going to be, x value is negative 2, and my y value is 0. Okay, so now let's go ahead and plot these on our x-axis. So it's going to be negative 4. So we'll put a dot here. Negative 4, 0 is here. That's one x-intercept. And then the other one is negative 2, 0. Okay, and those are our x-intercepts. Now for y-intercept, we do the opposite. We take our equation and we set x equal to 0 into our equation. So again, I like using the standard form because what you'll notice is there's a pretty easy pattern that happens here. So we're going to do y equals, and our standard form is negative 2x squared minus 12x minus 16. And all I'm going to do is, for every x, I'm plugging in 0. And what you'll notice is when you do that, your answer is always going to be your c value, or the number without the variable. Watch. So we want to know what y is. So for every x, I'm going to plug in 0. Okay, and what happens is 0 to the second power is 0. 0 times negative 2. All this turns into 0. Negative 12 times 0, that's going to be 0. And then we bring down the negative 16. And what you'll end up with is y is equal to negative 16. Okay. So we want to put this in point form. So point form is, now my 0 is x, and then my y is negative 16. Okay, so let's plot that point. 0, negative 16 is right here. It's on the y axis. So that's your y-intercept. Okay. Now I need a point symmetric to the y-intercept, but before I do that, I need to know the axis of symmetry. Remember, your axis of symmetry is a vertical line that splits my parabola into equal symmetrical parts. So how do I find the axis of symmetry? It's pretty simple. If you look at your x-intercepts, your axis of symmetry will go right in between them. Okay? So that's the visual way of finding your axis of symmetry. The algebraic way of finding your axis of symmetry is this. You're going to add x-intercepts and then divide by 2. So algebraically, if we had to do this using algebra, I'm going to add my x-intercepts, which are up here. So negative 4 plus negative 2. So negative 4 plus negative 2. And whatever answer I get, I divide by 2. So if we do this, negative 4 plus negative 2, that gives me negative 6. Divide that by 2. And my axis of symmetry is always x equals, and then we do this math, negative 6 divided by 2, that's negative 3. Okay, so here's my axis of symmetry. Again, it is x equal to negative 3 because it's a vertical line, and that's how we write vertical lines. So I'm going to draw that in with a dotted line. So axis of symmetry is going through x negative 3. So again, here's my axis of symmetry. It's not part of my graph. It's just a very important line that splits my graph into 2 parts. So axis of symmetry, AOS, it's x equal to negative 3 because it's going through the x-axis at negative 3. Okay? So I'm going to continue this dot all the way down. Okay, now that we have the axis of symmetry, we can go here and we can now do a point symmetric to the y-intercept. So we're going to find the y-intercept, which is this guy, and we want to copy him across the y-intercept. So basically make a mirror image of here. So if you look, he is 1, 2, he's 3 spaces away from the axis of symmetry. So I'm going to go 3 spaces away from the axis of symmetry in this direction. So I'll do that again. 1, 2, 3. we're going to do the same thing here. 1, 2, 3. And we're going to put a dot right there. Okay, and that point is going to be, let's put that point down. This point is going to be -6, comma, -16. So -6, comma, -16. Okay, and that's what we're going to put here. -6, comma, -16. All right, next thing is the leading coefficient. So let's go to standard form. Remember, your leading coefficient is essentially your A value. So let's go back to standard form. Our A value is the guy in front of the x squared. So my A value is -2. So my leading coefficient is -2. Okay, always your A value. All right, so now we can answer this question. If your A value is positive, so let me remind you, or your leading coefficient is positive, then you have a smiley parabola. If your A value is negative, you have a sad parabola. Okay, so if you look at our A value or our leading coefficient, it's negative, so it's going to be a sad parabola. We would call that opening down. The opening is on the down part. Okay, now let's go here. The vertex represents a minimum or maximum. So again, the vertex is the point in our parabola where the two sides of the parabola, the two symmetrical sides, come together. Okay, so it would be at the top of the mountain here. If we had an opening up parabola, it'd be at the bottom of the valley here. So if it's at the top of the mountain, so we have a parabola like this, our vertex would be a maximum. It's at the top of the mountain. Okay, so in this case, it's going to be a maximum. All right, so now let's find our vertex. Okay, so to find our vertex, we are going to take our axis or symmetry value. So let's go back. All right, guys, I got cut off real quick, so I'm just going to clip this to the end of the other video and try to make one solid video. But as I was saying, we just finished talking about the maximum value because it's a downward parabola, which means our vertex is going to be at the top of the mountain. So now we want to find our vertex. To find our vertex, we go to our axis of symmetry. If you notice, our axis symmetry actually gave us the x value of our vertex. So x equals to -3. That means my vertex has the x value of -3. All I have to do is now find the y value. To do that, I'm going to go ahead and take my equation. You could use standard form or factor form. It doesn't really matter. I'm going to go ahead and do factor form because it just looks simpler if I do factor form. And all we're going to do is wherever we see an x, we're going to plug in x equals to -3. Okay? You could do the same thing if you want to use standard form. You just plug in -3 for x. So let's do factored form. So in factor form, we have y equals -2 x plus 4 and x plus 2. So we're going to plug in our x value, axis of symmetry x value, into the x value here. So we're left with y equals -2, and it's going to be -3 plus 4 parentheses -3 plus 2 parentheses. Okay, and let's do this math. So y is going to equal -2 times negative 3 plus 4, that gives me 1, times negative 3 plus 2, that's negative 1. And then we do this math and multiply this out. So negative 2 times 1, that's negative 2. And then, so negative 2 times negative 1, that's going to give me y equal to positive 2. So now I know my y value is positive 2. I'm actually going to plot that point so that you should see that the vertex, it should be on the axis of symmetry. If it's not, you did something wrong. So it's negative 3 comma 2. So negative 3 comma 2 is here. And there's my vertex, which is also called the maximum point. Okay, and now let's connect these dots like a parabola. Alright, so something like that. Let's do a little better job. And there's your graph. Alright, let's go ahead and do number 10. Okay, so number 10, we're just going back to Algebra 1 or Im1. We're just going to solve for this problem. So number 10 says w minus 6 divided by 4 plus 2 equals 10. Our goal is to solve for w. So before we can even mess with this fraction, we want to get the fraction by itself. So I want to subtract 2 to both sides. Add 2 by subtracting 2. So we have w minus 6 over 4 equal to 8. Now, before I can get into the w here, I got to get rid of the fraction. So I don't like this bottom part. So to get rid of something that's dividing, the opposite of division is multiplication. So we're going to multiply both sides by 4. These cancel out, and we're left with w minus 6 equals to 32. And then last but not least, to get w by itself, we're going to add 6 to both sides. And w equals 38. All right? Hope this helps. Have a good one.